Good morning, students. Previous classes we have learned about inertia and its types. What are the types of inertia? Inertia of rest, inertia of motion, inertia of direction. Newton's laws of motion. There are 3 laws are there, but we learned 2 laws. Newton's first law and Newton's second law. Newton's first law is otherwise known as law of inertia. Newton's second law is otherwise known as law of force. Formula also we have learned and derivation also we have learned. I hope you all the students learned well. I am thinking. Did you learn, students? Okay, very good. Now we can revise first Newton's first law. Every body continues to be in state of rest or the state of uniform motion along a straight line unless it is acted upon by some external force. Next one, linear momentum. Momentum is defined as the product of mass and velocity. The formula P equal to m into v. P momentum, m mass, v velocity. The unit of linear momentum is kilogram meter per second. Newton's second law of motion. First definition we can revise. The force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of force. After the definition, you have to learn and write that derivation. The up to F equal to ma, force equal to mass into acceleration. Today we can learn about Newton's third law of motion. Sir Isaac Newton was 17th century discovered 3 laws of motion. Newton's third law states that for every action there is equivalent opposite reaction. In other words, if object A exerts force on object B, then object B also exerts equal force on object A. Notice these forces are exerted on different objects. They will not cancel each other. The third law can be used to explain rocket propulsion and the recoiling of the gun. Here, our some daily life situation illustrated Newton's third law of motion. When we walk on the ground, foot pushes the ground backward. That's action force. And the ground exerts the force on the foot. That's reaction force, pushing the foot forward. When a man jumps from the diving board, he pushes the board. It's action force. And the board in turn pushes the man towards the opposite direction. It's just reaction force. Birds while flying pushes the head downward with the help of the wings, which is action force. And the air in turn exerts the force to the bird in the upward direction is reaction force. Next one is impulse. A large force acting for a very short interval of time is called impulsive force. When a force F acts on a body for a period of time t, then the product of force and time is known as impulse. Impulse denote the letter J. Capital J, don't write small j. Okay, capital J. The formula for impulse is J equal to F into T. What is the formula for impulse? J equal to F into T. J means impulse, F force, T time. We can write here unit. What is the unit of force? Newton. What is the unit of time? Second. So, Newton second is the unit of impulse. Or we can write the unit kilogram meter second power minus 1. Momentum unit you have to write. Linear momentum unit you have to write. Or if you don't know this unit, you can write Newton second. Okay. Now we learned about impulse equal to force also there, time also there. You have seen that video now. So J equal to F into T. Force also there, time also there. So the formula for impulse is J equal to F into T. What is the unit of impulse? Newton second or kilogram meter second power minus 1. This equation number 1. Okay, first formula J equal to F into T. Take as equation number 1. Then by Newton's second law, already you have learned the force acting on a body is directly proportional to what you have learned? Rate of change of momentum. Like that you have learned, no? Rate of change of momentum. What is the formula for rate of change of momentum? Change in momentum divided by time. Change in momentum divided by time, only we have to say rate of change of momentum. Okay, this according to formula. We are written according to formula. The force acting on a, according to definition, the force acting on a body is directly proportional to rate of change of momentum. Okay, so rate of change of momentum, change in momentum denote the letter. Anybody know? Change in momentum denote the letter. So F force, you can write here equal to, what is the change in momentum? Delta P. Already you have learned delta P divided by time T. Okay, from here we can find delta P equal to, how will you find? Just to multiply this two. So delta P equal to F into T. So delta P, what is delta P? Change in momentum equal to force into time. Thus take as equation number 2. Can you understand, students? Delta P equal to F into T. From 1 and 2, see here also equation number 1 F into T. Here also F into T. So this side is same, no? So we can write here J equal to delta P. Okay, both the sides are same. So F into T here also cancel. So you will get J equal to delta P. So impulse is also equal to the magnitude of change in momentum. So the magnitude of change in momentum. Impulse is also equal to the magnitude of change in momentum. You know the unit of impulse. What's the unit? Kilogram meter second power minus 1. The impulse is also equal to the magnitude of change in momentum. So momentum unit you have to write here kilogram meter second power minus 1. Impulse unit also, momentum unit also same. So change in momentum can be observed two ways. Here change in momentum can be observed two ways. One is the large force acting for a short period of time. Large force acting for a short period of time, as well as a smaller force acting for a longer period of time. Like that, two ways change in momentum we can take. Large force acting for a short period of time. Here smaller force acting for a longer period of time. Then we can see some examples about this impulse. Look at this picture. Automobiles are fitted with springs and stroke observers to reduce jerks while moving on uneven roads. In cricket, a fielder pulls back his hands while catching the ball. He experiences a smaller force for a longer interval of time to catch the ball, resulting in a lesser impulse on his hands. These are the examples of impulsive force. Now see, a larger force acting with a short interval of time is called impulsive force. When a force F acts on a body for a period of time t, then the product of force and time is called impulse. So impulse means what and all there? Force and time also there. Next one is law of conservation of linear momentum. Look at this video. Two cars having the mass m1 and m2. First car mass m1, second car mass m2. With the initial velocity u1 and u2 in a straight line. Let the velocity of the first car is higher than the second car. During the time interval t second, they tends to have a collision. After the impact, both of them move along a same straight line with the velocity v1 and v2. These are the concepts for law of conservation of linear momentum. Then let us see how to prove the law of conservation of linear momentum. We can learn principle of conservation of linear momentum. Already you have learned momentum. What is the formula for momentum? P equal to m into v. P means momentum, m mass, v velocity. Here linear momentum. Linear momentum means what? Straight line. No, linear means straight line. Last year you have learned linear motion, circular motion. You have learned, no? So linear means straight line. So the body moves along a straight line. Like that we can learn. So momentum formula you should know. What and all there? Mass also there, velocity also there. Now we can learn the definition for conservation of linear momentum. I am writing here. So just to learn. There is no change in the linear momentum of a system of bodies as long as no net external force acts on them. Okay. Now listen, there is no change in the linear momentum of a system of bodies as long as no net external force acts on them. Here we are using here ball. Suppose we are taking two objects, two ball. This one, next one, two. Here this A, object B. The diagram very important. Now we can learn what is the proof of law of conservation of linear momentum. Okay. So let us consider two objects, two bodies A and B. So these two bodies also moving along a straight line. Moving along a straight line. The velocity is first one u1, second one u2. Okay. The two bodies, let us consider two bodies A and B. The mass, first one body mass m1, second one body mass m2. Okay. Let us consider two objects, objects A and B of mass m1 and m2 moving along a straight line, the velocity u1 and u2. Okay. Now after some time this body A is, this u1 is greater than u2. Okay, u1 is greater than u2. That means the speed of the object A is greater than the speed of object B. What happens? Do you know what happens? Two also collision takes place. Two bodies also collision takes place. This m1, m2. Okay, here collision takes place. This the force of body A and the force of body B. Also collision takes place. Understand? See it. First let us consider two objects of bodies. A and B. First body is A, second body B. The mass, first body mass M1, second body mass M2. First body force FA and second one force FB. Now moving a straight line. Linear momentum also moving along a straight line. The velocity is U1 and U2. After some time, the U1 is greater than U2. The speed of the object A is greater than the speed of object B. So, what happens here? Collision takes place. After collision, we will get to the object. Here this A and this B. A, B. This M1, M2. Here, the velocity after collision, the velocity V1 and V2. Okay, before collision, what is the velocity? U1 and U2. After collision, the velocity is V1 and V2. Okay, these are the diagram. Very, very important question. So, first you have to write definition. After that, you have to write a diagram. Diagram draw with the pencil. Don't use pen. Draw with the pencil diagram. You have to draw. Then force on body B due to A. The force on body B due to A. Okay, force on body B due to A, that is FA equal to the force on body B due to A, that is FA equal to here M2 into, you know the rate of change of momentum formula. What is the formula? M into V minus U divided by T. The second law derivation you have learned, M into V minus U divided by T. So here A means here you have to write 2. Okay, M2 into V2 minus U2 divided by T. So FA equal to M2 into V2 minus U2 divided by T. M means what? Mass. V final velocity, U initial velocity. Okay, this we can take as equation number 1. The next one, the force on body, here instead of B you have to write A, D2 instead of A you have to write B. So force on body A D2 B. So you have to write here. So here FB equal to M1 into V1 minus U1 divided by T. Okay, this you can take as equation number 2. So this according to Newton's second law, we have to write a formula M into V minus U by T. This which formula? Rate of change of momentum. So that formula we have to write here. A right means here 2, everywhere 2. Here B if you write, here everywhere 1. That keep in your mind. Okay. Then by Newton's third law of motion. By Newton's third law of motion. All of you know third law of motion. Action force equal to reaction force. Action force equal to reaction force. Why? Newton's third law states that for every action there is equal and opposite reaction. No. So we have to write here action which one? FB equal to minus FA. Why here minus? Do you know? For every action there is opposite reaction. Reaction everywhere opposite. So we have to write here minus. Okay. Then we have to substitute the value. You know the FB value, you know, then FA value also you have to know. So just we can substitute the value. Instead of FB, what's the value? M1 into V1 minus U1 divided by T equal to minus M2 into FA value V2 minus U2 divided by T. Okay. Then here the T and T cancel. We can cancel T and T we can cancel. Then you should multiply m1 into v1 minus m1 into u1. Multiply m1 inside. So m1 v1 minus m1 u1 equal to here minus m2 v2. This minus and minus, what will get it? Plus. So here write here minus m2 v2 minus into minus plus m2 u2. Then you understand this? Then here v1, here v2. Take one side, u1, u2. Take one side. Okay. So first m1 v1. Here minus m2 v2 equal to the side coming, so what will get it? Plus m2 v2 equal to, here already you got m2 u2. Here minus m1 u1 is there now, that you take as plus m1 u1. Okay. So first we have to write this before collision, this after collision. First we have to write before collision. Next we can write after collision. Okay. Equation number 3. See here we are not giving any external force. Okay. We are not giving any external force. U1 is greater than U2. So in the absence of external force, the algebraic sum of after collision, the algebraic sum of the momentum after collision is equal to the algebraic sum of momentum before collision. Last you have to write, there is no external force. The algebraic sum of after collision is equal to the algebraic sum of the momentum before collision. This much. Here you have to write 3 lines, you have to write after that. Okay. So these are the principle of law of conservation of linear momentum. Very, very important question. Last class one question we have learned Newton's second law derivation. So this one, the state and prove law of conservation of linear momentum. Very, very important question. Learn well, students. And if you have any doubt, you can ask. Students, worksheet for you. First question. State Newton's laws of motion. For this question, you have to write Newton first law, second law and third law. 4 mark question. Okay. State Newton's laws of motion. 3 law also you have to write. Second one, state and prove the law of conservation of linear momentum. First you have to write the definition for linear moment, for conservation of linear momentum. After that diagram, next derivation, then the last 3 line you have to write. Okay, this 7 mark question, this 4 mark question. Now we can mark in the book. Newton first law, every body continues to be state of rest or of state of uniform motion along a straight line unless it is acted upon by some external force. This is the definition for Newton first law. Next, page number 6. Newton's second law definition. The force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. Page number 7, third law definition. For every action, there is an equal and opposite reaction. They always act on 2 different bodies. Mark it. So first question, 3 law also you have to write. Second question, state and prove law of conservation of linear momentum. First you have to write the definition. There is no change in the linear momentum of a system of bodies as long as no net external force act on them. The next page. Let us prove the law of conservation of linear momentum. Draw the diagram. Here diagram is given. 2 objects A and B, M1 and M2. The initial velocity U1 and U2 moving in a straight line. Here collision takes place. After collision the velocity is V1 and V2. So you have to draw the diagram with the pencil. The next side getting proof. Let 2 bodies A and B having masses M1 and M2 move with the initial velocity U1 and U2 in a straight line. Let the velocity of the first body the higher than the second body, that is U1 is greater than U2. During an interval time t second, they tends to have the collision. After the impact, both of them move along the same straight line with velocity v1 and v2 respectively. Force on body B due to A, that is Fa equal to m2 into v2 minus u2 divided by t. The force on body A due to B, Fb equal to m1 into v1 minus u1 divided by t. By Newton's third law of motion, action force equal to reaction force. So, Fb equal to Fa. Then you have to substitute the value. And here one more line not there, just see the video and write it with the pencil. And the last final answer, m1 v1 plus m2 v2 equal to m1 u1 plus m2 u2. The above equation confirms in the absence of an external force, the algebraic sum of the momentum after collision is numerically equal to the sum of the momentum before collision. Hence, the law of conservation of linear momentum is proved.